Good morning, Math 3. Happy Friday. You should be watching this video on on January 29th, and I am absent. So today we're going to be continuing our task for our work in our book. We're going to be talking about how to have sine and cosine be a function of time, like a rotation, as part of the function. Yesterday you worked on some common trig functions, some common trig angles, and hopefully you took my advice and you made some flashcards. Those will definitely be very helpful in calculus. But anyway, let's get started today on the stuff from the books. Let me share my screen here. So this is where we are, task 6.2, sign language. And we're going to be talking about sine as a function of speed, or as a function of time, excuse me. So it says, in the previous task, you probably found Carlos's height at different positions on the Ferris wheel using right triangles. We kind of did that. We used sine and cosine. So these are some of the facts that we were using. So the Ferris wheel has a radius of 25 feet. The center of the Ferris wheel is 30 feet above the ground. Okay, so they have some information here that we already figured out, right? We figured out that each of these were 36 inches, or 36 degrees. We knew that that's 25 feet. And so this distance here would be 25 times the sine of 36. And so, you know, we figured out we already knew all that stuff. It says, Carlos has also been carefully timing the rotation of the wheel. This is important. And has observed the following fact. The Ferris wheel makes one complete revolution counterclockwise every 20 seconds. So the wheel is rotating this way, and it's going all the way around every 20 seconds. So we can express that in terms of degrees per second, but we'll do that in a second here. It says, how high will Carlos be 2 seconds after passing position A on the diagram? So it's a couple of different ways to approach this, right? If it takes 20 seconds to go a full rotation, then the fact that he is counting 2 seconds after passing position A means that he is 2/20ths of the way. You can think of it as he has completed this much of the rotation, or 1/10 of the rotation, right? So 1/10 of the rotation, if a rotation is 360 degrees, would be 36 degrees, right? So that's kind of one way that you can approach that. Another way you can approach it is if it takes 20 seconds to rotate all the way around, and we have how many sections? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections. That means that it'll take 2 seconds to go from here to there, right? 2 seconds to go from here to there, 2 seconds here to there. So you'll have 2, 4, 6, 8, 10, and that takes you halfway around, and then 12, 14, 16, 18, and then 20, and that's your full rotation. So just taking a little bit of time and really understanding what they're saying. So how high will Carlos be 2 seconds after passing position A? So after passing position A, 2 seconds means he's going to be at position B, and we already know that that's going to be, it's the 30 feet, right, from the base, right? The center of the Ferris wheel is 30 feet above the ground. So from here to here is 30, right? And then plus this distance, which is 25 times the sine of 36. And I believe that was like 44, but let's just double check it here. So you got 30 plus 25 times, oh, it's going to do it in radians, isn't it? Let's do it degrees here. We've got 30 plus the sine of 36 degrees times 25. Yeah, 44.7. Over here. So he's going to be 44.7 feet high, about. Okay, then it says calculate the height of a rider at each of the following times t, where t represents the number of seconds since the rider passed position A on the diagram. So they're about to give us a whole bunch of different time, and we have to find the height at each time. Keep track of any irregularities you notice in the ways that you calculate the height. As you calculate each height, plot the position on the diagram. So after 1 second, right? So at 1 second, if it takes this 2 seconds to rotate, so 1 second would be like halfway between. Oops. So 1 second would be like halfway between here and here, maybe like right around here. And that would be 18 degrees. So it would be 30, right? The 30 plus the sine of, or plus 25 times the sine of 18. So it would be 30 plus 25 times the sine of 18 degrees. So we can go back over here. History, sine of 18. Let's do it this way, plus 25 times the sine of 18 degrees. So it's going to be 37.7. Okay, 2 seconds we already knew. That was going to be 30 plus 25 times the sine of 36 degrees. And we said that that was 44.7 feet. Okay, 2.5 seconds. So we already know that 1 second is 18 degrees, right? There's kind of that, we knew that 2 seconds was 36 degrees. So we know 1 second is 18 degrees. So we know that half of a second is going to be 9 degrees. So we need 9 degrees past 36, right? Because it's a half second past 2. So it should be 9 degrees past 36. So 36 plus 9, that's going to go ahead and give us 45 degrees. Oops. Like so. And sine. Let's figure what that is. So let's come over here. Sine of 45. So it's going to be 47.7. Okay, and then this one, right after 3 seconds. So remember, each second is 18 degrees. So you would be 18 and then 18 and then 18. So it would be 54. So 30 plus 25 sine of 54 degrees. So let's come back over here. That's 50.2. All right, now if 3 seconds is 54 degrees, that means 6 seconds is going to be double of 54, or you could say 108 degrees. So you know what? I should have been doing this from the start. 30 plus 25 sine of 108 degrees. Let's go here, here, and degrees. So come over here, come over here. So that's 53.7. Okay. So 8 seconds is going to be 108 degrees. That's 6 seconds plus 36 degrees. Remember, every 2 seconds is 36 degrees. So another 2 seconds have passed, which means another 36 degrees will have passed. So that's going to be 30 plus 25 times the sine of 108 plus 36 is 144 degrees. Put that degree symbol in there. So let's go ahead and plug that in. Oops, let's do that. So it's going to be 44.7. And actually, that makes a lot of sense that it'd be 44.7 at 8 seconds, because at 8 seconds, that would be, so this would be 2, 4, 6, 8, right? And this height is the same as this height, and we already knew that that was 44.7, so that would also be 44.7. That makes a lot of sense. Okay, 14.5 seconds. So remember that each second is 18 degrees. So 14.5 seconds would be 14 times 18 degrees, and then another extra little 9 degrees for that 0.5. So we've got 14 of these, and then that 0.5 is going to be that 9 degrees from before. So let's go ahead and do that. 14 times 18 plus 9 degrees, so 261 degrees will have passed. 30 plus 25 times the sine of 261 degrees. Let's go here, let's go here. And that's going to be 5.30, or just 5.3 feet. So let's take a look at where that is exactly. So here's 2, 4, 6, 8, 10, 12, 14. So again, that's pretty close to the bottom. You're taking 30. You're taking this height of 30, and you're finding this height by using the sine, and you're subtracting it off, so that way you only have this height. That's really low to the ground, and that makes sense why it would be 5.3 feet. 18 seconds, so that's going to be here. We actually already calculated that, right? So that's 2, 4, 6, 8, 10, 12, 14, 16, 18. And we actually already calculated this up here. Where was it? Maybe we didn't. I thought we had. Oh, no, we did. 15.3 feet, right? So we already calculated that. Yeah. So let's go ahead and type that in. So that'd be 30 plus. So that would be, it's almost 360, but it's missing that last. So the way I'm imagining it, right, you've got that circle, and you will have gone all the way around like this, but you're missing that last 2 seconds, so you're missing that 36. So it's 360 minus 36, which would be 324. So 25 times the sine of 324 degrees. Okay, so that should be 15.3 feet, and so on and so forth. I'm going to let you guys finish this table, and you can kind of figure this out. Also, yesterday when we were doing like sine of 0 and sine of 90 and cosine of 90 and stuff, we really didn't go through and explain why those were what they were. But if you think about this Ferris wheel, it really helps to, like, what is the height at 90 degrees, right? Like that kind of helps you to understand what's going on. Anyway, so what I would like for you to do before Monday is to basically work on this set, right? So just these questions here, and work on them. You can work as a partner, you know, you can work in groups or whatever, but what I would like is if you had questions about them for Monday, questions for me to answer. So just all this stuff. Okay? All right, so have a great weekend, and I will see you Monday.